Right, so you've all probably heard of the robotic dog Spot. Some of you might not have. There's also a dog robot rather, from Ghost Robotics, which they're now putting a gun on, which I'll show you.
Applications, among others, for its QUGVs. This appears to be the first example of one of these unmanned systems with an actual weapon mounted on it. Unarmed examples of the QUGV are notably already in limited use with the U.S. Air Force's 325th Security Forces Squadron at Tyndall Air Force Base in Florida, and are being tested by other units within that service. The exact configuration of the 6.5mm gun inside the spur module, how much ammunition it contains, and how hard it might be to reload, are all unclear. Ghost Robotics has said that Spur can be instructed remotely to chamber the first round from an unloaded state, as well as clear the chamber and safe the gun. In terms of the weapon itself, SAR does offer derivatives of the 5.56x 45mm R15M16 family, as well as similar, but larger caliber guns, more akin to the Armalite R10 or Knight's Armament Company SR25. Those rifles come in calibers such as 7.62 51mm, 6.5mm Creedmoor.
Right, so yeah, basically with those calibers, the higher caliber 6.5mm Creedmoor round, usually with a round when it's fired from a gun, it will travel upwards and start coming down, um, due to just physics, I guess. The heavier rounds will have a flatter trajectory, should I say? So obviously they're thinking of using these heavier rounds for the weapon itself. But the thing is, on these, under like current legislation, basically, and it's going to sound good to start off with, these robots, they're going to have roughly a 20 round magazine. They're going to be able to acquire their own targets. They're going to, well, acquire their own targets. Basically, explain that a bit more. You've got a target 600 meters out in this direction, well, any direction. You're going to want to elevate the rifle slightly, obviously, depending on how far away the target is, to allow for the bullet's trajectory as it comes over. And also, you're going to want to offset it slightly, right or left, depending on how bad the wind is on a calm day, which is obviously not going to be likely. It'll just be the elevation for the bullet. And then obviously if you're on higher ground and you're shooting down, that's going to change your elevation characteristics as well, because the speed of the bullet's going to it's going to basically maintain velocity more going downhill. So there's a lot to sort of work out for a sniper, but obviously over months, years, they're trying to do this. This robotic system will account for all that itself and aim, acquire target. And then basically the law comes into it that that system cannot then fire. And that's going to sound good to start off with. You're not going to want that system seeing a civilian mistaking that for a military target and taking out that civilian. But it's also going to be, it's acquiring its target. It's going to be a matter of milliseconds, probably not even a whole second. And then the human phase is going to have to come in. And the human phase is someone watching on a screen from the robot, seeing this target and saying, yeah, it's okay to fire, so there's probably going to be a button on there. So it sounds good, doesn't it? It's found its target. Humans watching this screen, he now sees the target's been acquired, he presses the button. But that human phase, there's probably going to be a second delay from the robot saying, I'm ready to fire, to the human pressing the button. And then it's basically one operator per robot anyway, because unless it's quite a quiet battlefield environment, 5 robots, not much going on, one acquires a target, operator fires that. But in a hectic battlefield environment, you could have 3 or 4 targets. So that operator's now going, right, fire on this, I've got to check this screen, fire on that screen, okay, check this screen, fire on that screen, and so on and so forth. once you add in multiple targets, every time the robot acquires a new target, the operator then has to press fire again, press fire again, press fire again. Sounds good from a safety standpoint. It's also a good thing. The thing is, if we them, you can Russians, Chinese, other people are going to develop them, and are those countries going to have the same sort of system there, where the robot has to request to fire? Probably not. And that's where it's going to come in bad, because our robots, they're going to be requesting this fire thing, where the fully autonomous one is going to basically, it's going to see a target, and you think how quick a robot works compared to, or a computer works compared to a human, a lot faster. So their versions are going to be basically target, shot, target, shot, target, shot, target, shot, and basically totally outclass ours. I suppose we could have, I'm not sure how the law is going to work on it. We could have a law where our robots can find non-human targets and fire on their own. So in a robot, or I don't know, robot sounds a bit silly, doesn't it? But on a drone on drone situation, maybe the drones are just going to be able to take each other out, so on and so forth. But again, I can see legislation coming in place that it just cannot fire, because this drone tanks, anything could be shooting at this drone, and if that misses, could be a crowd of civilians behind, kills the civilians. So yeah, I think in this case, our legislation, although it's there for the right reasons, is going to royally buttfuck us, basically. But there, tech. I suppose I've got another 3 minutes on this video, so I might as well roll through a bit more of this one.
338 Lapua Magnum and 338 Norma Magnum. The weapon used in the spur module looks like it could have a sound suppressor fitted to the front end, which could make it more difficult for opponents to determine where the shooting might be coming from. The 6.5mm Kriegmauer is not currently in any kind of widespread use by the military or other security forces, either in the United States or elsewhere around the world. However, U.S. Special Operations Command is notably in the process of acquiring light machine guns and rifles in this caliber, ostensibly to fill an intermediate niche in overall performance between existing 5.56 45mm and 7.62 51mm guns, as you can read more about here. Testing has shown that this 6.5mm round actually offers increased range over the various 7.62 51mm cartridges that are available to the U.S. Special Operations community now. Ghost Robotics says that spur is capable of precision fire out to 1,200 meters, or nearly 3,940 feet. This unmanned system already features impressive stabilization capabilities simply as a result of its quadrupedal design. As for targeting, the spur module appears to have its own sighting system on top. In past testing the U.S. Air Force has conducted using unarmed QUGVs, operators have utilized the Android Team Awareness Kit, an app that can be installed on tablet-like devices, to interact with these unmanned systems and view the feeds from their onboard video cameras. It seems likely that attack or a similar piece of software could be used to enable a human to aim at targets and engage with them with the robot 6.5mm rifle. The Air Force has also discussed potentially operating QUGVs remotely from centralized command facilities via virtual reality headsets. SPUR could also have some degree of additional autonomy, now or in the future, potentially employing artificial intelligence-driven capabilities to at least detect and lock on to potential threats, even if an operator ultimately has to give the approval to start shooting. Sighting systems for small arms that offer these kinds of capabilities are available on the open market now. Regardless, giving the QUGV a weapon of its own offers a way for it to immediately prosecute any targets it might come across.